Welcome to today's lesson, Subtracting Mixed Numbers with Unlike Denominators. Today we are going to practice two different methods that you can use to subtract mixed numbers. Let's go ahead and get started. We are going to begin today by using the example 4 1/4 minus 2 1/5. We will be representing this using an area model. So I'm going to pull up an area model of 4 wholes and then 1/4 of a whole. Now before we can begin, we need to look at our denominators. We have fourths and fifths. These are unlike denominators, which means they are not the same. We need to create a common denominator for both of these fractions so that the size of the pieces in the fractions that we're working with are the same. In order to do this, we need to find a number that 4 and 5 are both multiples for. Let's use 20. We know that we can multiply 4 times 5 to equal 20. And if you multiply your denominator, you also have to multiply your numerator. So we just renamed 1/4 to be represented by 5/20. What would that look like on our drawing? There we go. We now have 20ths represented. But remember, we still have the same value shaded in, we just changed the size and number of the pieces. All right, let's rename 1/5. We're going to stick with our common denominator of 20ths, and I'm going to multiply 5 times 4 to equal 20. Since I multiply my denominator by 4, I'm also going to multiply my numerator by 4. All right, I think we're ready to subtract. We have 5/20ths shaded in. 1, 2, 3, 4, 5. We need to subtract 4/20ths. So we're going to subtract 1, 2, 3, 4/20ths. Now we need to subtract our wholes. We have 4 wholes shaded in. 1, 2, 3, 4. We need to subtract 2 wholes. 1, 2. All right, let's add up our wholes and our fractions. We have 2 wholes and 1/20th left over. Now, if we were to just look at our numbers, we would first subtract our fractions, 5/20ths minus 4/20ths. 5 minus 4 equals 1/20th. And then we would subtract our wholes. 4 minus 2 equals 2. Let's practice a word problem together. Macy is making a quilt. She buys 5 1/3 yards of fabric and uses 3 4/5 yards for her quilt. How much fabric does Macy have left? We already have our area model displayed below. We have 5 wholes and 1/3 shaded in. So let's go ahead and write our equation. We have 5 and 1/3 yards, and we're going to subtract 3 and 4/5 of a yard. All right, our first step is to look at our denominators. As you can see, we have thirds and fifths. They are not like denominators, so we need to find a number that 3 and 5 are both multiples of, so we can have a common denominator. Great! Let's use 15. If we multiply 3 times 5, we get 15. So since we multiplied our denominator by 5, we also have to multiply our numerator by 5. Now let's rename 4/5. 5 times 3 equals 15, and 4 times 3 equals 12. Our next step is to have our area model now represent 5/15. Perfect! Now remember, we still have the same amount shaded in, we just changed the size of the pieces. All right, our next step is to subtract our fractions. 5/15 minus 12/15. Uh-oh, we only have 5/15 shaded in. How can we subtract 12/15? That means we need to rename one of our wholes into 15/15. So I'm going to cross out one of my wholes, so I only have 4 wholes. And I'm going to break apart that whole into 15 fifteenths. So now we have 4 wholes, 1, 2, 3, 4, plus 15 fifteenths, shaded in here, plus 5 fifteenths. Now we can subtract 12 fifteenths. So we're going to subtract 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 fifteenths. So we've now subtracted our 12 fifteenths, and now we're ready to subtract our wholes. We have 4 wholes shaded in, and we need to subtract 3 wholes. 1, 2, 3. All right, I think we're ready to go ahead and add up our area model. We have 1, 2, 3, 4, 5, 6, 7, 8 fifteenths shaded in, and we have 1 hole left. That means that Macy is going to have 1 and 8/15 yards of fabric left over. Let's try another word problem together. Maxwell has 5 3/4 pounds of fruit. He gives away 3 1/8 pounds of fruit at soccer practice. How many pounds of fruit does he have left? We have 5 3/4 minus 3 1/8. Since we're dealing with fourths and eighths as our denominator, we need to find a number that 4 and 8 are both multiples of. But we're in luck because 4 is a multiple of 8. All we have to do is multiply our denominator and our numerator by 2, and that gives us 6/8. Now we just have to subtract. 6 minus 1 equals 5, and we keep our denominator the same. Now we have to subtract our whole numbers. 5 minus 3 equals 2. And that's all there is to it. So Maxwell will have 2 5/8 pounds of fruit left over. Let's review what you've learned in today's lesson. When you're trying to subtract mixed numbers, it's important to first look at your denominators. If your denominators are not the same, you need to come up with a common denominator. In order to do that, check out your denominators and try to find a number that they are both multiples of. 5 and 2 are both multiples of 10, so we're going to use 10 as our common denominator. I have to multiply 5 times 2 to equal 10, and since I multiplied my denominator by 2, I also have to multiply my numerator by 2. 2 times 5 equals 10, which means I also multiply my numerator by 5. Your next step is to subtract your fractions first. 8/10 minus 5/10 equals 3/10. Then you can subtract your whole numbers. 9 minus 6 equals 3. Now sometimes you're going to find that your fractions aren't going to subtract easily. You need to make sure that your first fraction is greater than your second fraction. And if it's not, then you need to rename a whole. We can't subtract 5/10 from 2/10. So I'm going to rename one whole to be 10/10. And then I'm going to add that to my 2/10. So I now have 12/10. Now I can subtract. 12/10 minus 5/10 equals 7/10. And now I can subtract my whole numbers. 6 minus 3 equals 3.